Tonight's video is day 3 of section 4.5. We'll be doing U-substitution again, but also even and odd functions. The homework tonight is a little bit different than the handout that I gave you. I have eliminated a couple of problems, I believe 4 problems. Your homework tonight is 93, 95, 97, 101 through 103, 105 through 110. So we'll begin with the U-substitution component. So we have a definite integral. It's definite because I have an upper and a lower bound from 1 to 5, x squared times the square root of x minus 1 dx. Now please notice 96 is within here, even though I'm not doing one of your homework. The reason I say write it out is because the directions in the textbook tell you to not do it by hand, but to actually use a graphing calculator. I actually want you to practice the algebra and write it all out. You can check it with the graphing calculator if you know how to enter it, but otherwise I need you to write it all out. So I'm going to go ahead and let u equal what's underneath the square root, x minus 1, and I went ahead and I rewrote this in case I need it to isolate the x. But let's continue and take the derivative of u equals x minus 1, which would be du equals dx. So now this dx will be substituted by the du, and the x minus 1 will be the u. So what I did not get rid of is the x squared, so I will need this. I'll have to substitute in for that x a u plus 1 and then square it, just as I did here. So now to continue, again this is multiplication here. I need to go ahead and multiply that all out so then I can multiply that in. So yes, this is going to be a long, lengthy, taxing algebra problem. And so what I did is u plus 1 times u plus 1 gives you u squared plus 2u's plus 1 times my u to the 1/2. So then I went ahead and did that. Remember, what you have to do is you add the exponents when the bases are the same. So 2 can be rewritten as 4 over 2. 4 over 2 plus 1/2 is 5/2. To the first power is 2 over 2 plus 1/2 is 3/2. And 1 times u to the 1/2 is u to the 1/2. Now I'm actually ready to integrate that. And so that would be 7/2, and then divided by 7/2, or else multiplied by the reciprocal. 2 times u to the 5/2 over 5/2, and then the 2/5 I went ahead and I multiplied by the reciprocal. And the 1/2 would be 3/2 divided by 3/2. I took the 3/2 and I multiplied by the reciprocal. I think you're getting pretty comfortable with that from the bounds of 1 to 5. First thing I have to do before I put in the 1 through 5 is resubstitute back in my u, which is x minus 1. So that is by just resubstituting that u with an x minus 1. And then I cleaned up that 2 times 2/5, which is 4/5. Now I'm ready to do this. So I'm going to enter in the 5, which would make that a 4 all the way across. Then please notice when I put in the 1, that will be a 0. That's awesome. So really all I have to do is put in the 5, which I'm going to produce a 4. So I went ahead and I did that. I got a 4 for each of those, and I started to do the work, and I noticed that was just 0. Now at this point, please notice that all of these have a 2 in the denominator, so 7/2 can be broken up into 7 times 1/2. 5/2 is broken up into 5 times 1/2, etc. You can choose which one you want to apply first to that 4. I like trying to choose the square root first so I can get that number smaller before I multiply. So in each of these, I did the 1/2 component to square root it to get that 4 down to a 2. What I have left is then to the 7th power, to the 5th power, and to the 3rd power. So now 2 to the 7th power is 128, 2 to the 5th is 32, 2 to the 3rd is 8. Multiply that by that fraction. And because I'm not going to make a common denominator, because technically this problem said for us to use a calculator, at this point just enter it into your calculator and you should get approximately 67.505. So that was a taxing, straightforward U-substitution by using this extra technique that we did today in class. Next, we first studied even and odd functions in Precalculus last year, whether you were in honors or regular. That was in Chapter 1 and used it periodically. Just as a small review, the way you tested the function is you dropped in a negative x. When you put in negative x into the function and got the original function, we called it an even function. And an even function has symmetry about the y-axis. An odd function, when I dropped in the negative x, it would produce the negative or the opposite of the original function. An odd function, when you graph it, has symmetry about the origin. So I went ahead and I graphed out two examples from Precalculus. An even function would look like this. Again, when I put in my negative x, that would produce an x squared, the same as the original, and that's reflective over the y-axis. This one here, if I put in a negative x and then cubed it, I'd get a negative x cubed, which makes it an odd function. That's my cubic. And please notice what we've been doing with the integration, that's area under the curve. Again, it's trapped by the x-axis, so this area is the same as this. These are identical. So if that's got an area of 2, so does that. But this one here, these two are the same, except this is a positive area and that's a negative. So when I add up these two identical areas, it would be 0. So that's actually how they write this up. It says, so, if f, my function, is an even function, then when, example, we'll take it here from a to negative a, from a to negative a, for that function f of x, like x squared, then it's really 2 of just 1/2 of it, from a to 0. It's double, right? If I know half of it, then I just times it by 2. Well, this is half of it, from a to 0. But if f is an odd function, then we already know that the area underneath the curve is 0. That's positive, that's negative, and that's identical because it's got symmetry about the origin. So we're going to use this also to help us integrate. So in the directions, it actually will then tell you to use even and odd functions to help you integrate. So let's see what that might look like. From pi over 2 to negative pi over 2 sine of x times cosine of x dx. So here's my function. I need a test. So I wrote it out, and then I tested it out. I put in negative x for where the x is. And if you remember from Precalculus, the 2 out of the 6 trig functions that are even are cosine and its counterpart secant. Sine, cosecant, tangent, cotangent are all odd functions. So this produces the negative sine x, this produces a cosine x, so this entire function is now an odd function. It's the opposite of the original. So now that I know that this is really an odd function, since f of x, we'll call this f of x, is an odd function, we just discovered that, then this integration is just 0. In other words, don't do the work. We know since this is an odd function, and you're going from my a to my negative a, the same values, just a positive and a negative of that, it's going to be 0. Just think of that cubic function I have just drawn up there for you. Let's try another problem. I'm going to use the idea of even and odd. So I'm going to give you this. Let's let from 2 to 0 for x to the 4th power dx equal an area of 14 underneath this curve. I don't know if that's right or wrong. I just picked that number out of my head. Let's go ahead and take a look at this for just a moment. You probably already know this answer, that this is an even function. Okay, so this is an even function. Again, I've written the answer there. So let's say I take it from 0 to negative 2, x to the 4th dx. Well, this is 1/2 of it on one side, and this reflected over the y-axis. This is the other half. So if this right-hand half is 14, so is this left-hand half. Sorry, I'm trying to just show you all the answers. Let's try another one. Use this, then what? From 2 to negative 2, x to the 4th. Well, if half of it is 14, and since we know this is an even function, I can rewrite it as it's 2 of these halves. 2 of these halves means it's 2 of those 14s, which means the whole thing is 28. Again, think of the parabola I had just sketched out with an even function. If I know half of it, I can just double it. I'm going to do another one. So what I'm going to do is I'm going to extract out that negative. Now, I already know that answer. It's above, right? We already know that it's 14. So the area must be negative 14. Because why? This function has been reflected over the x-axis, so it's upside down. So I'm taking area up to the x-axis, which means it should be a negative area. Last one. So from 0 to negative 2, that's the left-hand side, 4 times x to the 4th. Let's just take out the 4. Well, we already know what this is. We've already done that earlier. It's 14. So it's 4 times 14, which is 56. Last problem today. Use the symmetry of graphs of sine and cosine to help integrating. Now I want you to think about it graphically or go sketch it out in order to think about how to do this. So if I give you this, I know you've already seen it over here, from pi over 2 to negative pi over 2 sine of x dx. I'm asking you to remember this. You need to remember this from pre-calc, how to graph sine of x. So here was one period that we graphed in pre-calculus, and you can get that from the unit circle. It starts at 0, goes to 1, goes to 0, goes down to negative 1, goes back to 0 for one complete rotation from my theta or my x. I went ahead and I scooted it back because I'm going from pi over 2 to negative pi over 2. So right here, you can see that this is an odd function. And we already know sine is an odd function. And so this area is identical to this area, but this is positive, this is negative. So based on the graph, it is 0. Thank you.